So we're going to do just a quick review of the overall immune system and then talk more in-depthly about the adaptive branch of the immune system. So we know that the immune system is a military, if you will, that we have inside of our body to protect it from foreign invaders, harm, etc. We have two different branches to the immune system. We have the innate branch, which again, innate is born with. So we are born with it. The Lady Gaga branch, as I like to call it, we're born this way. It is fast acting. It's non-specific. Sorry, it's supposed to be non-specific. And sometimes it can be localized. Our other branch of our immune system is adaptive. And that we acquire, so we have to acquire this one. It's based on our germ exposure, so we have to acquire. It's slower to act, but it is specific, so it's going to fight against a specific germ, and it's supposed to be a C, and then it is systemic all throughout the body. And our innate immune system makes up our first and second line of defenses. And then our adaptive makes up our third line of defenses. And we talked about how this is kind of like when we were fighting the Revolutionary War, when you had lines and lines of people that could fall in battle that really weren't all that skilled. And then our third line of defense is like our SEAL Team 6, super duper specific. I want to very quickly go over the pieces that are part of the innate immune system. Again, just as a quick review. So in the innate, we have our first line of defense is our skin and intact mucous membranes. So those are physical barriers that are going to prevent substances from breaching our fortress, okay? So we talked about how the skin and the mucous membranes were like the wall around a castle, physically preventing things from getting to the inside. And then we have some different specializations of the skin and mucous membranes. We have the acid mantle of the skin. We have acid that is produced in the stomach, acid that's produced in the vagina. You have a lysozyme, which is an antimicrobial agent that's produced in our tears and saliva. You have cilia and you have hair that are specializations of the mucous membrane. Again, all there to prevent substances from getting past our physical borders. Now, if something does get past our physical borders, we have our second line of defense in our innate immune system, and that is cells. And our two types of cells that we talked about were natural killer cells and phagocytes. And the natural killer cells, sorry, I'm at the end of my slide here. The natural killer cells were non-specific T lymphocytes that can recognize virus or cancer-infected cells and will kill them using a substance called perforins. And phagocytic cells are like macrophages, monocytes, neutrophils. They can go eat dead, dying cells, bacteria, or any other debris. Then we have antimicrobial proteins. And that was complement and interferon. Sorry, this pen I have is pretty much awful. Complement and interferon. So complement is those 20 different blood proteins that exist in our plasma that will do very similar things to as antibodies. They can attach onto germs. They can cause them to precipitate, fall out of solution. They can neutralize them, basically like, bond all the way around something and prevent them from doing any harm. Complement proteins can basically create such a a big structure that it can rupture the membrane of something and cause it to lyse. And then interferon is given off by virus-infected cells, so that cell is not going to make it. However, the interferon is going to attach to neighboring cells and interfere with the virus spreading to neighboring tissues. We have inflammation. I guess I'm right. Inflam. So we have redness, swelling, heat, and pain are our 4 cardinal signs of inflammation. You should be able to explain what causes that. And finally, we have fever. So that is a systemic response to white blood cells giving off that chemical called pyrogens that gets picked up by the hypothalamus. The temperature gets reset. It goes higher, and so the rate of metabolic activity in the body goes up, as well as the liver and spleen hang on to their free zinc and iron, which will decrease bacteria from being able to proliferate. So with the adaptive immune system, so this is the one that we acquire throughout our lifetime. I told you there are 2 different generals that are running 2 different branches of this system. We have the humoral branch and the cellular branch. And the humoral branch is run by the B lymphocyte. And the cellular branch is run by the T lymphocyte. And I talked last week about the B lymphocyte kind of being like the godfather. So when you watch these mob movies, the godfather really isn't the one that's going out and doing the dirty work. It's its henchman. And that's kind of like the B lymphocyte. So the B lymphocyte itself, it's going to recognize the antigen that it's meant to fight. However, it's not the B lymphocyte that is actually going to go do the dirty work. It's going to turn into 2 different types of cells. It's going to turn into something called plasma cells and memory cells. And it is the plasma cells that are actually going to produce the antibodies that look like a Y, which are going to go out and affect antigens. So it's not the B lymphocyte itself. T lymphocytes, however, the B lymphocyte can roam around and recognize an antigen, T lymphocytes are responsible for like cell-to-cell combat. But they cannot recognize whole antigens. They can actually only recognize antigens that have been chewed up, and a fragment of them has to be presented to them. So they require antigen presentation. I can't finish the word, I don't know, from antigen presentation. And that is done either by professional antigen presenting cells or what I like to call amateur antigen presenting cells. And we'll talk more about that when we get into this. But this is the adaptive branch run by 2 different generals, B lymphocytes, T lymphocytes. B lymphocytes are going to be involved with antibodies, which are chemicals that go in our humors or our fluids. The cellular branch involved with T lymphocytes, and they cause killing. All right, T lymphocytes are going to directly kill other cells. However, before they can do that, they have to have the antigen or fragment of the antigen presented to them in this process called antigen presentation. I'm gonna do 2 different videos, one about the humoral branch and then one about the cellular branch.